Hi folks, Professor Gray here. We need to talk about measuring things with the metric and the imperial sides of a ruler. So I've grabbed this handy dandy little teal object off of my desk, and I've gotten a ruler from my junk drawer, so please don't mind this blob of whatever that is right there. So let's get started. If you take a look at the top of the ruler, what you'll notice is that we've got big lines and little lines. And if we're trying to determine whether it's the metric side or the imperial side of the ruler, we'd probably look over here and go, aha, the mm is millimeters. Now, that might lead us to think that the millimeters are the big numbers right there, since that would kind of sort of make sense. But no, the millimeters are the little dashes up here. The bigger dashes, or the bigger numbers, these guys right here, those are your centimeters. So again, the little graduations or the little dashes, those are millimeters, and the bigger ones are centimeters. Now, if you want to count the millimeters per centimeter, you would find that we have 10 millimeters for every 1 centimeter. But that's something you should remember from chapter 1. All right, so how would we measure the length of this teal object? Well, let's do it in centimeters first, just because the centimeters are the bigger ones. So what we do is we look over here and we say, aha, this teal object is 7 and a bit centimeters. So we go ahead and we write down that number. And we are certain that we have 7 centimeters and not 6 and not 8. So we will say that this is certain right there. And what we'll notice is that not only is it 7, but it goes beyond 7 to right about there. And if we take a look between the 7 and the 8, you'll see that you have this kind of longer dash right there. That's where you have 7.5. And it looks like it goes not only to 7.5, but 7.6 and then 7.7. And we can see that with our eyeballs pretty well. Some of us might need to put our glasses on, but we can pretty much see that. Now, what we need to do that most students don't want to do when we measure things in chemistry is we need to go ahead and then make a guess. Okay, so if we're looking at this, we might say, that looks like it goes slightly past 7.7. So let me go ahead and call that 7.71. Your lab partner might come by and say, oh, no, that looks like it's 7.72. And maybe the person who is across the room from you walks by and says, no way, that's right, exactly at 7.70. And you would all be correct because the last digit is uncertain. That's our guess. Okay, that's where we're going to have a little bit of wiggle room right there. All right, so we would have 3 significant digits there. And if we were to put that in the worksheet that you have for this lab, what we'll do is we'll say, okay, let's have a teal object here. And we're doing centimeters. So we go ahead and put 7.71. Again, if your partner thinks that it's 7.72, that's fine because that last digit is uncertain. That's our best guess. That's where we have wiggle room. Now, you see how you have centimeters written up here? That means that everything in that column is going to be centimeters, so you don't have to put a unit. But if you want to just be safe, you can go ahead and put the centimeters there. Okay, so scrolling on back up. Now, we have this interesting concept of level of precision or uncertainty in our measurement. And we already talked a little bit about that when we said that you need to make a guess on the end. And if you look at where you made your guess, it was in between 7.7 and 7.8 right there, okay? So this one right here is 7.7, and that one is 7.8, and both of those are centimeters. And if we don't zoom in on it, if we just leave it as normal, we might look at it and go, oh my goodness, that space in between 7.7 and 7.8 is super small. I can't make it out. So I'm just going to say if the object is between the two of those, I'm just going to say it's like halfway in between. And if this is the case, then you most likely would just go ahead and put that we have a level of uncertainty of plus or minus 0.05. Now, what you'll notice is that the 5 goes to the same column that the 1 did there. Okay, so we're talking about uncertainty here, so it should make sense that it's going to the same column. And that's what it's going to do all the way through this lesson. Okay, now another way to think about it is that between 7.7 and 7.8 right there, you have a difference of 0.1. Halfway between a 0.1 would be 0.05. Okay, so we're saying that that space is so small that if something is between there, we'll just say, I don't know, it's halfway between there. Okay, now if you have super good eyes and you want to say, oh, no, I can definitely tell where 7.70, 7.71, 7.72, and 7.73 are because my eyes are that good, I might put plus or minus 0.01. So you're saying, okay, I'm going to make a measurement of 7.71, and I'm pretty sure that that's right on. So I'll give a level of uncertainty of plus or minus 0.01. So I'm pretty sure it's 7.70, 7.71, or 7.72. So that would be if you could make out where the 0.01, 0.02, 0.03 is between the 7.7 and the 7.8. So if you can see it better, that number in your level of precision, your level of uncertainty is going to be smaller. And if it's hard to make it out, you're going to just go, it's halfway in between, and you'll have 0.05 there. Okay, so where do we put that? Well, that goes down here. So level of precision for your measurements, or level of uncertainty, however you want to say it, we would say 0.05. Now notice again that we go to the hundredths column here and we go to the hundredths column there. It is always going to correspond. And then it will be the same all the way down because you're using the same measuring device. You probably don't have 4 different rulers that you're using that all have different levels of precision. All right, so how would we write that on a quiz or a test so we got full points? Well, we would have to remember to go ahead and put centimeters on the end. So we would have 7.71 plus or minus 0.05 centimeters on that one. Now, how about we read it in millimeters? Because that was the first thing that was on the table anyways, millimeters. Well, we could go, we already defined this. We have 10 millimeters per every 1 centimeter. So I know that that is just going to be 77.1 millimeters. But this is a measuring lab, so you guys should probably measure it and make sure that you're doing it correctly. So if we take a look at what we talked about earlier, about how this area right here is either 10 millimeters or 1 centimeter, what we could remind ourselves of is wherever we have 1 centimeter, we would have 10 millimeters. So we have 0 and 10, 20, 30, 40, and on millimeters there, okay? So that means if we go all the way over here that we've got 70 and 80 millimeters there. So what happens is that this right here, it's no longer 7.5, now that's 75. And that right there is 76. And right there is 77. And right there is 78. So we can see that in between here, where our teal object measures to, it's in between 77 and 78, which makes sense when we consider that we just wrote, oh, if we just change 7.71 centimeters into millimeters, it'll be 77.1. But again, we're gonna be measuring it. So if we look at this, we can see, okay, I've got 77, and the teal object slightly goes past 77.0. So I'm gonna call that 77.1. Now, if your partner says, no, it goes a little further, I think it's 77.2, and your brother comes on into the lab and takes a look at your stuff, which he shouldn't be doing, but maybe he puts on goggles and wanders in and says, no, I think it's 77.0, who's correct? You're all correct, because the first 2 digits here are certain. You can see those on the ruler. You have graduations, or you have dashes for those. And the uncertain value comes in between here where we don't have dashes. So you have to make a guess. So that is your uncertain position right there. Okay. So when we go to talk about uncertainty for the millimeters, what we learned in the centimeters section is that we're going to do plus or minus 0 point, and we're going to go to the same column that we went to with our measurement, and this is the tenths column. So with millimeters, we would end the level of uncertainty in the tenths column. Now, again, looking at that space between 77 and 78, it's really, really small. So we probably can't make out very well where 77.1, 77.4, 77.8 are. So most of us would just go ahead and put plus or minus 0.5. So not only does that go to the same column that our uncertain number goes to, but the other way to think about this is that we're going by ones here. So we're going 76, 77, 78. So each one of those increments is 1 millimeter, and halfway between 77 and 78 would be 0.5 millimeters. And so that's going to correspond right there. So you're saying 77.1 plus or minus half a millimeter, because I can't really see in between there very well. So if it's in between, it's halfway in between. Okay. And if you feel like you can see it better, if you can make it out better, then maybe you want to put plus or minus 0.1. Again, this ends in the same column, the same place where we have uncertainty in the measurement, okay? And you're saying it's 77.1, and I'm pretty sure of my measurement. So I'm gonna like lower the uncertainty there and say I'm so sure of it that it's only gonna be plus or minus 0.1. So it could be 77.0, 77.1, or 77.2. I'm very sure. Okay, so that would be legitimate too. What you'll also see is sometimes we'll have plus or minus 0.2. Sometimes you'll see that, okay? All right, it just kind of depends on what the scientist who's making the measurement feels about their uncertainty when they're the one making the measurement, okay? All right, so say we don't want to lose points on an exam, so we would go ahead and make sure to put our unit here. So that measurement is 77.1 plus or minus 0.5 millimeters. And what do we do with this information? Well, we go on down here and we say, okay, 77.1. And you can write millimeters if you'd like, or you don't have to because it's already up here. But watch out because sometimes it's not up there and you'll get docked points. And then for our level of precision, that is this right here. So if you feel like you can't see it very well, just say halfway in between my smallest increments. And your smallest increments for the millimeters were 1 millimeter. So what you have is halfway in between is half a millimeter. Okay. And then we go ahead and we move on to the imperial side. All right. So looking at the ruler measuring in inches. Now, measuring in inches is kind of weird because we have to do fractions. And nobody likes fractions. So let me point out that in between 0 and 1, let me do red. It shows up a little bit better on the teal background. What we have is a series of dashes, and on some rulers, they're going to be 16ths, and some rulers, they're going to be 8ths. My ruler tells you that there's 16ths of an inch right there. It tells you 1/16. Now, if you have 16ths, you're going to have more dashes or more increments than if you have 8ths, okay? So we have 0, and then we have 1/16, and then the next one is 2/16, which is the same thing as what? As 1/8 if we reduce it, okay? And notice how the 8th, that dash is a little bit longer than the 16th. And the next one, that is 3/16. And then the next one right here, that one is 4/16, which reduces to what? To 1/4. Okay, so that longer one right there, that is 1/4 of an inch, or we call that a 1/4 inch. Now we have 5/16 here, and we have 6/16 here, which reduces to 3/8. And then right here, we have 7/16. And then here we have 8/16, which reduces to 4/8, which reduces to 2/4, which reduces to 1/2. Oh, we have to remember fractions. Oh no. Okay, so that's a 1/2 inch right there. And notice how the increment or the dash is a whole lot longer than the 1/4 inch dash, which is longer than the 1/8, which is right here, which is longer than the 16th. So those dashes help you see what's what and where it's at. Okay, so then the next one would be 9/16, 10/16, blah, 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 all the way up to 16/16 right there. And anything divided by itself is what? Is 1. Okay, so 16/16 is 1 inch. Whew, all right. Now that we've got through with that, let's go ahead and do the measurement. All right, so we're looking over here and we can see that we've definitely got 3 inches there. We're not at 2 inches and we're not at 4 inches, which is way out here. So we're certain that we've got 3 inches. And then we're going to go ahead and read to the next column. And we can see right here that it's not quite reaching to 3 1/16. So right there would be 3 1/16. So we'd have to call this 3 0/16. Okay, now we have to make a guess to the point where we don't have any dashes. That's why it's a guess. And in between 16ths, what on earth is that? Well, I'm going to have to go back over here and point something out. So notice that we have 0 and we have a 1/2 inch right here, okay? And we have 1 inch right here. Now, 1 can also be written as 1/1. Half of 1/1 is 1/2. And half of 1/2 is 1/4. That's right here, okay? And half of 1/4 is what? Is 1/8. And half of 1/8 is what? It's 1/16. So half of 1/16 right here would be what? 1/32, 1/32, okay? So halfway in between all of our dashes, we're going to have a 32nd. All right, so we have 3 is certain. We are certain that we have 0/16. We do not have 1/16 yet. And then you have to make a guess. So we have our uncertain. And what on earth would we call that? Well, it's somewhere in between 3 0/16 and 3 1/16. And I'm just going to make it easy on us and say, it looks halfway in between for me. So I'm going to say we have 1/32. Okay, now I can make that more difficult on myself and say, well, it doesn't quite look like it's half. Let's mess with the fractions a little bit more. But no, I don't want to do that, okay? I just don't. So let's just say it's halfway in between there, and we're going to call it 1/32, okay? Because in between all of our 16ths, halfway in between there is 1/32. Now, because we have 0/16, most of the time we're not going to see that. Nobody's going to write 0/16 because 0 divided by anything is what? It's 0. So you have no 16ths, why write it? So you would go ahead and write 3 1/32, okay? So this teal object is measuring 3 1/32 of an inch. Now, how sure are we? Well, I would go ahead and say plus or minus 1/32. Now, saying the 32nd here and here is the same thing as saying we're going to the hundredths column here and the hundredths column here, or the tenths column here and the tenths column there. So that's why we're going to go ahead and do that. And because the uncertainty is at the 32nd, you gotta get the in your mouth there. 16ths and 32nds. Okay, so we'd say that we have 3 and 1/32 plus or minus 1/32, and we want to make sure we get our points, so we'd put inch, and that would be the answer. And we would go ahead and scroll on back up here and put 3 and 1/32, and we put plus or minus 1/32 there. All right, so what happens if this measures a little bit bigger? What if, let me do some erasing here, just so we can do one more example. Let me go ahead and make something up here. Because for most people, this is kind of like, what? So what I'm going to do right here is I'm going to say, how about I don't have a teal color, so I'll just do this green right here. How about this measures a little bit more than this right here does that? Okay, so it's like, wee. Okay, so if our object was out there, what we would say is, okay, we've got 3 for sure, and it's not 2 and it's not 4, so that's certain. And then we have 3 and 1/16, 3 and 2/16, 3/16, 4/16. So we'd have 3 and 4/16, or you'd have 3 and 1/4. And those are both certain. Or we can say this one, and let me go around like that one. So you have dashes for those 2 increments, okay, those 2 measurements. And then you want to go ahead and make a guess, which is right in here, okay? So you can barely make out the next dash that's right there, okay? So what we would say is, okay, in between 4/16 and 5/16, so right there is 4/16, which is also 1/4, and right there is 5/16. What we're going to have is a 32nd. Okay. So remember, that's just halfway in between. So if we were doing the metric system, it'd be like 0.5, or half of 0.1 is 0.05. Half of a 16th is 1/32, okay? So that's just like saying halfway in between. All right, so that is the complete measurement there. So our uncertain point is right there, or same thing right there, okay? Now, before, the middle part, so right in here, was a 0, so we ignored it. But here, we have all of these things. And remember, with fractions, you can only add them if the denominator is the same. So unfortunately, we have to do a little bit of math here. And so we have 3, and our 4/16 needs to be turned into 30 seconds. So in order to get to 32, what we'll have to do is we'll have to multiply the bottom by 2, because that would give us 32. And what you do to the bottom, you have to do the top. So you'd have to multiply that by 2 also. And that gives you what on top? 8. Okay, so then we'd have 3 and 8 30 seconds. And then we also have another 30 second. So what we'll do is we'll add all of these up. And how we write that is we write 3 and then we add the 8 and the 1, which gives us 9 over 32. Okay, so our measurement would be 3 and 9 30 seconds. Ay, 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 right? And we're not even done yet, because we have to do our level of uncertainty. And that would be plus or minus. And we're just going to do the halfway in between these two guys right here and say, okay, halfway in between a 16th, and again, we're between 3 and 4 sixteenths and 3 and 5 sixteenths there, is a 32nd, okay? Just again, like halfway in between 1 is a half, is 0.5, and halfway in between 0.1 is 0.05, and halfway in between a 16th is a 32nd, okay? And then what we're gonna do is put inch on the end there, okay? Now again, that was just this made up object that I did over here so we could do another example. So what we're saying here is our measurement is 3 and 9 30 seconds, and we're pretty certain that it's either 3 and 9 30 seconds, or 3 and 8 30 seconds, or 3 and 10 30 seconds, okay? Alrighty, so the last thing I want to talk about is the right-hand column on your lab for part A, and that's your ratio of your centimeters to inches. Now, in chapter 1, what we learned is that for every 2.54 centimeters, we have 1 inch. And that's a metric to imperial comparison, and that is exact. So we don't expect you to get 2.54 centimeters all the way down the column, because you guys are new to this class and you're new to measuring like this. So if you get 2.52, 2.54, 2.56, things like around 2.54, you're doing a good job. If you get 1.98, I would do your measurements again. So how are we going to figure out what goes in this box? Well, the other way that we can write this ratio right here, my friends, is by saying 2.54 centimeters per 1 inch, or we could say 2.54 centimeters per inch, or 2.54 centimeters per inch. It's all saying exactly the same thing. It's just writing it differently. So what we're going to do is we're going to take our centimeters and put it on top like we did here, and our inches and put it on the bottom, and see what ratio we get. See if we get close to 2.54. So we go ahead and put 7.71 centimeters there, and we put 3 and 1/32 inches there, and then we go, we have a fraction and a fraction. What do we do with that? Oh my goodness, we're doing decimals and fractions. Okay, I feel you on that. But you can do a couple of things. What you can do is you can say, okay, let's go old school on this. And 1 and 1/32, if I wanted to turn that into an improper fraction, I would do 32 times 3 plus 1, which would give me 97, but you have to remember that it's just not 97. You have to keep the denominator and throw it over there, which makes 97 divided by 32, which is 3.03. Or you could just do 1 divided by 32 and see that you get 0.03 and add that on to your number 3 right there. Either way, you're going to get 3.03. So what we have is 7.71 centimeters divided by 3.03 inches. And what you get for that is 2.54 centimeters per inch. I should have measured a little bit not as accurate, so that we got something like 2.57 or something like that. But trust me, my friends, you do not have to get exactly 2.54 because you're learning. You're new at this. All right. I've been doing this for decades now. I'm old, and so I'm pretty good at it. So you would go ahead and you'd put 2.54 right there. And again, the label's up here so you don't have to put it, but sometimes it won't be up there. So if you just want to be careful and go ahead and put it all the way down, you can do that. Okay. So again, you guys, if you're getting 2.52, 2.56, 2.51, you're good. You're on the right track. If you get 1.75, you need to do your measurements again. Now, the average of the ratios above, you're going to add up all four of these. And since you have 4 digits, you're going to divide that by 4. If you are adding up 3 measurements or 3 of your ratios, then you would divide it by 3 to get that average. So that's how that works. And this is the 3rd time that I have recorded this video. So hopefully this time the microphone was working. Okay, that's it for today. Bye-bye.